missing on Monday. I thought I can make the schedule on Monday morning because I had an overnight flight from the West Coast, but almost it's exhausted, so I couldn't be here on time and also the lecture. So I asked GA to show the blockchain, the video, then please submit the summary of that. So I schedule the 1 or 2 days of the blockchain, but if we have a time, we will have a time to talk about that. But by the way, the one of graduate student from the technical management, whose name is Wei Wu, he founded the blockchain company, startup company, the Wilmington. Is there anyone, the town of Wilmington in Connecticut? I never heard about it. Yes, it's the northeast, the part of Connecticut. So anyway, he will visit. Actually, they're supposed to come to UB this evening, but moved to the after Thanksgiving. So if you have an interest on the blockchain, so you can come by the NoSQL database class on November 28th. I will remind you one more time after Thanksgiving. So today we are going to continue the lecture for the chapter 12, and if we have a time, the 13th. But by the way, before we start, I was informed the result of the project 1, the implementing the share, your own share, the implementing the share. But almost half of students probably get the 0 mark. If you got the 0 mark, that means it's pressurized. So you copy the other. It doesn't matter who is the source or who is the original, as long as GA and me find any copied, pressurized one, the both or the group of the submission were marked as a 0. Okay, no exception, no excuse. So instead, I'd like to give the one more chance to do the project again. So if you got the 0 mark because of the pressurized, the copied, so you can resubmit. So this time, fully by your own work. Okay, do not copy and paste. Do not the pressurize. If you do by yourself, so maximum 70% of the project 1, the maximum. I think there is 100 marks, but 70% the maximum. That will be much better than the 0 mark. So it's some of the students say that I just find the code from the internet, I just recycle, but it's different from the recycling or the just copy and paste. Okay, most of the case, those who got the 0 mark even doesn't change anything. Some of the students just the copy and paste even the comment with the other student name on the source code. Really. So if I and or the GA find one more time from your second chance submission, one more time any pressurized or the plagiarism, it will be the automatically the F fail your entire course. Okay. So please, during the Thanksgiving, the due date is end of the Thanksgiving holiday. During the Thanksgiving holiday, please do the project by yourself. So even though it's not completed, it's incomplete, it's okay. You will get those amount of your effort for your result credit. So, Gita, why don't you create the resubmission site for the second chance, the submission of the project 1. So if you have any up here, first quickly check whether you are grade as pressurized or not. Then if that is pressurized but you don't accept I do by yourself, if you believe that you did the project by yourself, come by me, then I will check it again. Okay? So otherwise, think about the second chance submission for the project 1. Any questions? Okay, so Today we are going to go for the file system implementation that is based on the file system, the file structure, file and the directory structure that we have discussed last week. So it's more focused on how to implement the file system based on our discussion on the file system interface in chapter 11. So also this one will be helpful for the project, the second project. Okay. So file system, as we discussed, I moved a little bit speed up, okay, because we need to cover the chapter 12 on Monday. So usually it's a 2-day class, but hopefully I try to finish. But before I start, I attended one conference, which is not the fully academic conference, but we usually share the what we are currently doing in terms of research, in terms of the teaching in computer science. So mostly the presentation topic follow the kind of a trend of the computer science and the IT environment. Then the 99%, really 99% of the topic is related to the AI and machine learning right now. No matter what area the researchers are doing, like the bioinformatics, the computer vision and computer graphics, network security, anywhere they are using the AI, even the operating system, hardware, chip design, so they focus on how to accelerate such AI or machine learning. So I don't believe we give up or throw away such the conventional topic in the computer science database, and database is much related to data analytics and the machine learning, but operating system, somebody said we don't need the operating system. I don't think so. That will be also the changes that follow the trend of the such a computer application. Like if we need something more computation, like the TensorFlow, as we have seen the GPU, the chip is developed that the speed to accelerate the computation of the machine learning. Operating system also focus on the such a thing. So then one of the important part is the file system. File system, as if you have a chance to take the big data or the NoSQL database, so they solve the problem of the size of the data based on the file system. It's actually a distributed file system. It's a divide and conquer. If one is not enough, so we can make the number of the nodes. Then we use the distributed file system. So this file system is actually the basis of the solution for the big data, something like that. So I believe such understanding the concept of the file system is very important to understand such a big data solution also. So what is a file system? File system is a software to manage the data on the secondary storage. So the slide shows the overview of the layered file system. Actually, file system is not just the software that manages the data. For example, we are using, for example, NTFS. So, however, beyond the NTFS, there are many other software. Some of them are considered as a file system. The others are device program. That shows in this slide. So, for example, this is hardware. This is application program. Eventually, application program use the data stored at the device. Then this device, as we have seen before, so controlled by the controller. This controller. That is I/O controller. This I/O controller, or this controller has its own program, embedded program. Sometimes it's called a device program. So this device program knows if you remember the device, this device has the formatting. Has a format. It's a logical block address. It's a low-level formatting. Okay, so it's from 0, 1, 2, 3, 4. So I'd like to retrieve the block 1, 2, 3. Then this controller, device controller, or the device program know how to access the data, like moving rotating the disk, the 90-degree or the head movement from left to right, then finally access the data. This is the job of the I/O controller or disk controller. And also to manage the I/O controller, it has the program. It's a basic file system, mostly embedded program. Okay, that is a part of the device program. Okay, then to use. This is the also logical block, addressing is a block, then the file and the logical block. This is called the logical block. So has the something module to match it. It's a map between the hardware and the logical block. So it has the you can see that it's called matching the logical block, and physical block is this one. Logical block is from the file system. So if you already start the second project, so first your job is you divide the file system file, like for example 10K, and divide by the block size. Like I try to use 512 byte. So 512 byte, 512 byte, block number 0, 1, 2, 3. This is a logical block. And each block matches to the logical block is 0, 1, 2. So this one is matched to this one matches this one is this, like that. So that is the job of the file organization module. And finally it has the file system. So if the file system that we know, that we use it, is this one, logical file system, like the NTFS, FAT, 16, 32, ext2, ext3, ext, whatever. Any file system that we are using from the operating system is this logical file system. Then this one, as we discussed before, has basically the file, definition of the file. What is a file, and we talk about that. Then directory, in case we have the number of files, many files, so we can manage such a number of files using the file control block. File control block is a metadata. So just like the process control block in the process table. So we keep all the metadata of the processes. This file control block keep all the metadata of the file. So then the file system actually manages such the file control block. So that is the file control block. And sometimes it's called inode. Inode is almost the same concept. You probably heard about inode. Inode is the different name of the file control block mostly used in the Unix system. So that means is the file system. In case of portable file system, this is a file system area. It's a logical file system. Then divide by the number of blocks. So first block is used for the metadata, header information that keeps the number of the FCD, the file control block. So the a.txt file is here. So the file name and when it's created and the block number and so on. This will be managed in the file control block. So sometimes this file control block is called the inode, mostly in the Unix or the Linux system. Okay, so main job of the file system. So if you implement a portable file system, you have the kind of data structure, definition of your file and the directory. So in the portable file system, you are going to implement what? Single level. Okay, you are not going to actually create the directory. It's more complicated, so you don't have to worry about the directory structure. Instead, you need to define what is the file control block, and for each file control block, what kind of information you are going to keep. So for example, my portable file system has the information about the security. Who can access, what is the access permission. So in the file, as an attribute of the file control block, you can keep such information, the permission information, or the created date and time. So you can create another attribute of the file control block for the create date and so on. Okay, so each of them are discussed here. I already mentioned that. So such a logical file system is based on the file control block. In case of the Unix, is called inode. Also, it has the directory management and all the interface, file system interface that we have discussed in the last class is already discussed there. Then what else? So we have the file system FAT, FAT32, NTFS. The UFS is a Unix file system. It's mostly used in the Linux like the file system. And then the ext2, 3, 5, 8 are the extended file system used in the Linux system mostly. And nowadays, even application program create their own file system. So like the Google actually developed their own file system, Google File System, 2002, 2003. Then at that time, Google need the general conventional file system cannot manage the huge number of the file. Actually, what the Google is doing is collect all the web page and copy. So if you search sometimes the Google, if the site is not available, you can just see the cache the file, which means that the Google actually visited the website when that website available, copy, download. So you can see such a cache data. So which means Google actually collect, copy huge number of files in the file system. So conventional file system is too many. So they think about the different way of managing such a file. They develop the Google file system. Eventually, so Google actually released the data structure of the Google file system. Then it is the project of Apache Foundation, which is the Hadoop distributed file system. Finally, this is the kind of the father or the ancestor of the Hadoop distributed file system for the big data solution. So just like also Oracle. Oracle uses a lot of file system as a storage of their database, relational database. So one time, it's a funny story. Oracle realized that if anyone who ever installed the Oracle database management system, if you can try, you can download for educational purpose, Oracle TechNet and so on, then they ask minimum size of the hardware. Like the CPU should be at least the quad core or the 8 core, and the memory size at least 4 GB or 8 GB and so on. And if we install the Oracle database for the server, actually it uses most of the CPU power and 60% of the memory and most of the space storage, which means the server is only for the database server. So they realized that the Oracle thought, instead of installing the Oracle database on top of operating system, sometimes it's hard to, if there's a new version of operating system or the new hardware, they need to deploy the new version of Oracle database. What if they include the operating system as a part of the database management system? Because the main job of operating system is a kind of interface between the hardware and user. Then a lot of time, Oracle database access directly hardware, the secondary storage, and also memory management, and also they monitoring the processes. So it will be better. They thought it will be better if they include operating system as a part of DBMS. So they thought about such the database-oriented operating system. So as a part of such a project, they thought about their own file system and so on, but actually failed. So nobody wants actually to install the Oracle database that includes the operating system. So it was a fail, but it may be possible. So some of the application, the build, so especially the file system, some of the application use their own file system to store the data and manage the data. Okay, so when we implement, and right now, so far we have talked about what are the data structure of the file system, and so on. So we are ready to implement the file system. So if we start the implemented file system, that's exactly the same as what you guys need to do when you do the project portable file system. But this portable file system is minimized. So we focus on the data structure of the file system plus, for example, think about to use your portable file system. If you list the ls, all the file, you should be able to access all the header information, FCB, and check the file name. If this command is A, the all and L long. So you need to access all the information about your FCB or inode, right? So it takes a time to access this one, this one, this one, this one. Instead, we can copy the header information to the memory. So when you implement the file system, actually we need to consider two parts. One is the data structure on the file, secondary storage, plus the memory data structure, disk and memory data structure. So if we copy the cache, this header information to the memory, okay, then the application, the process can access the data about the information about your file and file system from the memory. So we can speed up. So this is called the memory data structure. It's a memory. So you are able to use such an approach in your portable file system also. Okay? In your program, you define the file control block. So you can instantiate. So if you are using the, for example, Java, so in the Java, you can create a class for the FCB. So if somebody create a new file, you can instantiate on the memory first. Okay? Then from time to time, you can synchronize the FCB for the a.txt file on the memory in your program. Then write back to your file system. It's a synchronized. Okay? From time to time. You can use such a, you don't have to directly create the FCB on the file system, on the disk. Instead, you can create the first on the memory, and from time to time, or last, at the end of the application, you can actually write to your memory, the disk. So it's up to you on the implementation, but it's not required. So you can directly write the data information to the file. Or you can use such a memory structure. So you need to think about the two things, the on disk and the memory structure. The reason why we use the memory structure is to speed up. So it's an efficiency problem. Also, the file system also includes the boot control block. As we discussed at the beginning of the semester, the first process is called the kernel. Kernel actually pointed, referred by the one. So when we start up our computer system, so what happened? So first BIOS program is running, so checking all the devices, and the BIOS program also know which one is the partition that include your kernel. Then if you go to that partition, it has the boot record, master boot record, and address of your operating system kernel file. Okay, so that is called the boot control block. So file system also has the boot control block and other header information. Okay, so then the plus, it has the, as we have discussed a lot, it has a file control block. So one more time, file control block has all the information about your file, metadata information. It's up to you. So when you implement your own file system, the portable file system, for example, depending on the requirement. So what the functionality you have, so you can use the file permission, or if you don't care about the permission on the portable file system, you don't have to include this one. Totally depends on what you need in your application. So regarding to the in-memory file system structure, I'm going to use this slide. So this is the secondary storage, this is the memory, and this is the application. This is the same thing. So this one is when you read the file. So when you read the file, so think about your portable file system. From your application, like you start your file system application like the PFS. Then I'd like to list or read the specific file. At the time, you need to copy the FCB to the memory. So memory in the memory, kernel memory, is not the operating system. It's not the application, the memory, mostly such a file system use the kernel memory, and where you can copy the FCB to the directory structure. In your portable file system, we don't care the directory structure. You can just use some of your application program. So it's not the kernel memory we are pretending. So you can use the application program, but anyway, so you can copy the FCB. If there is no such a file, I would like to create a file, for example. Then you can create the new FCB and in the memory and the secondary storage also. So you can bring and from time to time the synchronize. When you write a file, so you need to always, we need to manage the, when we use the resource, three steps. So when we use any types of operating system resource, we need to open the resource and use it and close. For example, if we use the file f open and access the file and f close. For example, the memory, this is a file, memory, so we can malloc and use the memory and dealloc, your location, like this. So when we open the file, so this the open file. So one application, one process can open number of files, right? We need to manage such a resource. So in the per process open file table, using what? File control block. Okay. Then the system-wide, some other process also open the file. This is a process 1, process 2. So this process also manage the open the file. Actually, not only the file, but any other resource. But in this file system, we meant the open per process. Process 1 has number of the open the file list, and process 2 has a number of open file list. Then access also system-wide, overall entire operating system. Then who opened such a file. So for each file, how many? Which process are open. So system-wide open file table. So you can manage the two table. One is the per process which files are open, and the system-wide the file which process are using such a file. So this is another the memory structure in the file system. So keep in mind, you are in the file system, it's not just the secondary storage, disk files, the data structure, but also we have the memory data structure also. Okay? Then we already talked about the mounting. Okay, so such a file system is can be mounted to the mount point, then we can use in the file system. So because of that, we can have in the one operating system many different file systems. Not only NTFS or UFS, we have the process file system or something temporary file system, object file system, and so on. But how can I use such a different heterogeneous file system? So to address such a problem, we have the virtual file system. Okay, virtual file system is kind of standardization. So we have for example, A file system, B file system, another file system like the NTFS. And on top of that, we have the virtual file system. So virtual file system actually provides such a standard operation. So that includes open file, close the file, read the file, write the file, memory map file, and so on. Very basic operation standard. So each file system implement this one. Okay. Then when you access the file from A the type to the B type, they go through this standard function. So on top of that, there are virtual file system interface. It's actually not real the file system, it's the interface. So you may not realize whether you are copying from A file system to the B file system because of such a virtual file system. To implement the directory, so naive way, how can you manage a number of file controller? Linear list. If you think about the linked list in your data structure, it's a linear list. Okay, and if we have the many of them, you can see sometimes some of the file system use the B+3. Have you seen the B+3 before? It's a indexing structure used in the relational database. So actually B+3 is not only for the database structure, so nowadays it's also used for Android. Use the B+3 for the Lite version, SQLite, the indexing structure in the Android application also. So B+3 basically use the balanced tree. It's a tree structure. It's a balanced tree structure. So their performance is so good. So because of that, relational database, 99% of the indexing structure used in the relational database is a B+3. So in the directory, to manage a number of files, file control block, they are using B+3. Also, we can use a hash for the implementation of the directory. The hash is the function for the complicated data into simplified data. The one of the very basic example of a hash function is modular. So if you use the modular by 5, any of data, it doesn't matter it's a novel style, the ASCII code or the whatever image, it can be one of 0, 1, 2, 3, or 4. So one of these 5 is called the hash key. So using the hash key, then you can create the hash bucket. It's the room to keep all the data that share the same hash key. So we can narrow down such area to find the file using the hash table. Definitely, just like any other algorithm that are based on the hash has the collision problem. Collision means even though input data are different, their hash key may be the same. So that is a hash. So you need to address such a collision problem for the better performance. So another issues to implement the file system is I'd like to create an a.txt file. Here, it needs the full blocks. So let's say 500. It's a 2K size, the file. So you need to allocate the 4 blocks. How to allocate? How to allocate the block? So that is the allocation problem. So first, easiest way, contiguous allocation. Contiguous allocation, if you can find the continuous block, in this case, for example, the count. This is a directory structure to manage the number of files. So count is the start 0 to length 2, 1, 2. And the TR is from the 14, 1, 2, 3. And the main is starting from 19 block, and it's a 6. So 1, 2, 3, 4, 5, 6. So always contiguous. So for example, if I create the file size 4, this is starting 2, 3, 4, 5. We can allocate it. This is called the contiguous allocation. Benefit? Easy to implement, right? And also, how many bytes do you need? How many information? Start and length. It doesn't matter how long or no matter how long your file is, you need to always need the starting and the length. Then we can find the data. At that time, one of the common mistakes on the photo file system implementation, do I need to keep all the location, like do I need to mark this is a block 0, block 1, block 2, block 3? No, you don't have to. You can use just the file, then calculate the offset using the offset. For example, block 0 always start offset 0. Block number 1 is 512 the byte, and block number 2 is 1024. What? Then block number n is how to calculate? N times 512. That's it. You can calculate always. You don't have to mark where is the starting of the block. Okay, so you can calculate the such an offset of each block. So in this case, if you have such information, you can calculate the offset. Directly go to that offset using the random access, then read the data, read the file. So that's it. So it's easy to implement. Problem? Memory.
They may not be used.
So which means it's called fragmentation. You heard about the fragmentation issue. So like for example, I like to create I need a block, 7 blocks. Okay, my file is the 3.5K. So we have enough free block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 free blocks, but I cannot create the file. That is the fragmentation problem. So contiguous is easy to implement and pretty much reasonable the performance, but problem is the fragmentation issue. Okay. So to address that one, next the approach is extend-based the allocation. Extend means instead of contiguous, but I'd like to create the five block as one extend 0. This one is extend the 1. This one is group of the contiguous block is called the extension. So it's bigger than the block, one block, okay? But it doesn't have to be fully the contiguous. So for example, I need 7 block. Then I can allocate one extend the 0, and extend the 3. Extend the 3. So it is not fully connected, but extend is the number of the contiguous block. Okay? So like the 4 or 5 contiguous block. Then we can reasonably address the problem of what? Fragmentation. Okay? So using the extend. Problem is, in case of 7 block we need 1, 2, 3, 4, 5. So 1 extend, 1, 2, 3, 4. So the other 3 blocks in 1 extend we cannot use. So this is called the internal fragmentation. It's a fragmentation issue even though we have the available space inside the extend we cannot use. It's called the internal fragmentation. So extend-based approach is used a lot in the real application, including database system. So database use extend-based allocation. So this is called the extend. Then linked is, as you can imagine, linked list is if I need the 3 block, 1, 2, 3, like the linked list. So we can use such a linked allocation like this one. So in the directory, so we can point start only. Start 9, and this one point the 16, this one point here. So the last block is marked as the null. So also to verify the end of the file, we can include in the FCB we can include such a last block also. What if the file is appended, extended? Then we can use go to the directory, the last block, and allocate another block and point and update this one. This is a linked. Okay. Benefit? No fragmentation. Yes.
But how is it linked the blocks to each other? Based on what? Like who decide which block is linked to the other block?
Who decide the next block?
Next block.
So for example, here I need another block. Okay. Then we can use we are going to discuss how to manage the free block. Okay. So from the free block, let's say the free block managed from the lowest block number 0, 2, 3, 4, 5, 6, 7. Okay. Then we can allocate the first free block. So this one point 25, 25th block point the block number 0. Then update the last end block as a 0. Okay? So that is the algorithm to allocate, to find the free block in your file system using the linked allocation. Benefit? No fragmentation issue. You can use any block in your file system. Problem? When you read the data, you need to always start from the beginning. It supports only the sequential access. Okay? No way. Where is the data in the middle? Because unless you visit all the block, okay, you don't know the location of the block. So random access is not available in this case. So you need to utilization is good, but performance is low. Also, it's not the major problem, but each block you need to allocate the pointer to the next one because it's linked, right? So maybe if you are using the 4-byte integer, you need to use the 4-byte. Not the data, for the pointer to the next one. So that is the linked allocation. In your project, I think it's a contiguous allocation, right? You can use the contiguous allocation, which means it's the simplest way to implement. Additionally, I can implement other allocation like the linked. You can do that, then there may be extra point, but focusing on the contiguous allocation. Okay? Then, the problem is how to manage the free block. Okay? Before that, this is an example of what? Pointer start, and next, and finally, the last one. It's a linked allocation, right? So this is called the file allocation table. We have the directory structure. This is FAT. So old version of the Windows use FAT16 and also 32. Right now, it's not fully used. NTFS or other file system are popular, but this is old version of the linked allocation. So FAT use the linked allocation. Then to manage the FCB, actually FAT use the B+3 instead. Okay. There's another one which is called the indexed allocation. So using this slide. So there's a file, it points only the indexed block. So this indexed block has all the list of the block number used in this file, which means 9 block is the first one, 16, 1, 10, 25. So first to access the file, go to the directory FCB of the zip file, and the index block is the 19, going to the 19, and the first block is the 9, second block is the 16, and this one. -1 means it's a null, which is allocated but not being used yet. Okay, so you can use for future. So it's allocated but it's not used block. So next time when you extend, when you add more data, you can use this block in your file system. This is indexed allocation. Benefit? You can implement random access. You can just go to this one, the index block, and calculate the offset location of your data. Problem? Yeah, you need to manage the indexed block. It will be bigger and bigger if you have more and more data. So old version is still being used. There is an ISAM file. The ISAM file is the indexed sequential access, the management file. It's used in the IBM, the machine, the mainframe, the machine use ISAM file. ISAM file actually includes such an index inside the file. Okay, so you can actually use such an indexed the data to access the data very fast. So this is an indexed location. What if index is bigger and bigger? We can make another index. Eventually, this is the search tree. It's a big tree index. Then This is a combined scheme used in the Unix file system. I know the structure. So for example, single, double, triple indirect means level of index. Okay? The higher level you have, the bigger size file you can cover. The problem, it takes a longer time. One more level, you need to access one level, another level. So if your file is big but not frequently accessed, you can use the triple indirect. However, if your file is frequently accessed and a small file, you can use the direct block. Then the plus other header information. So actually, this is one of the questions asked by my old teacher, the operating system class. So for the using I know the structure used in the Unix file system. What is the largest file size, the file system size? You can actually calculate. Using the given information, that will be answer is always 4 GB. It's not bigger than 4 GB. So, but I couldn't calculate all of that. So, but I knew the answer, so I write just the answer. Then I couldn't get the full credit. But if you actually calculate the triple and double, single, and the direct block and accessing all the given information, it will be the 4 GB. Because of that, the old version of the file system, there's a limitation of the file system size. So you can create up to the 4 GB file. You cannot create the file bigger than the 4 GB. Nowadays, we are using the 64-bit. 4-bit has also upper bound the limitation, but almost impossible to create such a big file. So sometimes we say there's no limitation of the file size in the 64-bit. Okay. Yes, the free space minimum. To manage the free space, the easiest way is the bitmap. So, for example, we create a portable file system. There are total 32 blocks. And we can create the 4-byte. So first, the 8-bit, total 4-byte. Allocate a 4-byte where? In the somewhere your header information. So 4-byte will be used to manage the free. How can we manage? Then we have the 1 means all the blocks are free. So this one is to indicate the first block. This one is the second block. So block number 0, block number 1, block number 2, block number 3, like this. So if you create the file system, all the bitmap is 1. Then if you allocate the first 4 blocks for the file, 1, 2, 3, 4. If you allocate the 4 byte, then change the value into the 0. So 0 means used, 1 means free. Then how can I find the free block efficiently, fast? How can you find? You can check where is the first one. Okay, that's the free block. You don't have to calculate, you can use the instruction. Most of the CPU, the chip, general purpose chip, provide the instruction to find the first. Where is the first one? So example is FFS, CTC, or other. Using the instruction, which means it's very fast to find the first, the one from the bit, the free space. So in your implementation of a file system, you can default the first initial size is 10K, right? And what is the block size in the project?
56.
56?
250.
256. Then how many blocks? 10K divided by 256 is 40. So if you need a 40 block, means how many bytes do you need? 5 bytes. Okay? So you can create allocate a 5 byte for the free space. Then the mark all 1. But some of the block will be used for the directory information, header information. So I'm going to use the first 4 block for the header, okay, directory structure. So which means this one will be automatically 0. And 1 will be start from the fifth, the byte, the bit, 111. So you can allocate this one for the contiguous allocation. So instead of the creating array, many of the students create the array. Okay, so like the array, the 40 or something like that. Instead, why don't you create the bitmap? Why don't you use the bitmap to manage the free block? That is the easiest way and fastest way. Okay. Okay. There's a free space management. Okay, then the performance. So anyway, our files, the files in the file system is stored at the disk, the secondary storage. So which means it will take a time. So most of the case, whenever I probably mentioned several times, considering the history of computer and computer science, computer engineering, whenever we encounter problem of the speed, efficiency, there are 2 ways to address that problem. First, develop faster device, faster CPU, faster memory, faster burst, faster something. But that's not always enough. The second approach is using cache. We can use a cache. Meaning is, because not always, most of the case, we are not going to access all the data. It's sometimes called the 20-80 rule. So only 20% of the data are accessed. The other 80 is archiving purpose. Think about your cell phone. How many the files you are accessing? How many photos that you already to the people? How many of them you display and see? It's a few of them. So why don't we put such a frequently accessed data on the faster device? So that is a cache. So we can use such a cache approach to speed up, to manage the file in the file system. Okay, so that is the buffer. So we can use such a buffer for the I/O. However, I skip the memory management. The chapter 9 and 10 we will cover after Thanksgiving. The memory also has their own cache. Okay, so we can use the buffer cache for the file system, but the memory actually used such a this is application, and this is the memory structure. Memory structure also used the cache, which is called the page cache. Okay, to access the data. So which means it's a double buffer. Double buffer looks like good, but it's really complicated. Actually, that confuses a lot of the problem. So think about the memory uses the page cache, but it's cache. But such a main data is also cache of cache. So it's much more complicated. When somebody accesses this buffer cache, like the file system accesses the buffer cache and update. But this update data is not in the buffer cache. So 2 layers of buffer cache is really confusing. So to address that problem, so most of operating systems actually combine into one buffer cache, unified buffer cache. So buffer and the cache for the memory page, don't worry about too much what is the page. It's the I/O unit used in the memory. We will talk about a lot after Thanksgiving. So this page cache, the memory cache, it's called the double cache. So we can combine into one unified buffer cache. So that is like this. So memory map I/O or application I/O, they use the same cache area on the most of the file system. Okay. So we will talk about the page and the memory mapped I/O, the page cache in the chapter 9 and 10 after Thanksgiving also. Okay, so that is another issue. So when you implement the file system is recovery. What's the meaning of the recovery? Recover. something happen, we go back to the original. So when I actually joined my first job, my supervisor, he mentioned the two things regarding to the database administrator job. The DBA should keep the two important things. So one is, the first job is backup. So in case we cannot actually avoid the failure. Nobody knows when it's going to be. Sometimes simply somebody unplug the power, then your system will be failed. Really happen. Okay. Or we believe the UPS system. UPS is unstuck the power supply, but it may be happen is something damaged. So or who knows, 9/11 entire the site will be collapsed and the natural disaster. So we cannot actually avoid such the disaster or the problem, but we should be able to restore or recover. But to do that, we need any backup data. So backup is the first job of the administrator. Okay, but I never back up my personal information, personal data. That's the problem. But anyway, then second job. Do you think what is the second most important job for the administrator? First one is backup, and second is documentation. So documentation, skill is the next thing. Experience is the next thing. But no matter what happens, you need to keep track of such a problem or the history and everything. It's a documentation. Believe it or not, nowadays it's much better. There are the automated tool or the system to keep track of such an event. And you have the log data, so we back up all the log data for further analysis, but still not many of the administrators, they keep track of such the history of their system. So documentation is very important. So first job is the recovery, to do the recovery, which means we have the failure. The failure is not just the system or the disaster recovery, something like that. Sometimes transaction level, there might be failure. Network level, so your network is not reliable, not always. So sometimes it will be disconnected or the pending. So that's also considered a failure. So we should be able to recover. That is a recovery, the file system level. Okay. So most popularly used file system, the recovery is using the log. Log is kind of a backup. Not backup, but the log, archive. So it's called the log structure file system. Meaning is, let me give you the simple example. So this is the block, data A. Okay? So we update the data. So when you update the data, most of the system, file system, does not update in place directly A to B. Okay? Instead, this one will be copied to the unified buffer memory. So this will be copied A, then change it into the B. Okay? Then this one is still A, on the memory is a B. If somebody read the data, it's a B from the memory. Okay? Because we are using the buffer to speed up and so on. What if power is disconnected at this moment? So we lose the data in the memory, it's still A, right? But supposed to be B. So at that time we can use the log structure. Log structure means when you update the data, even though data is changing to the B, but in the log is always stable the storage, secondary storage, not in the memory. So update A to B. This command or the operation or the system call are stored on the log. Okay, but in the still A, if power is out, we lose the data. When we start the system, System check the log and the real data. Update A to B. It's supposed to be B, but it's still A. Meaning, we need to recover. That is the file system recovery, restore. So, this is called the redo operation. We need to redo using log file. If you already took the NoSQL database, so some of the NoSQL database use such a log structure to keep the consistency. So any update the data is on the log structure. This is the log. So sometimes it's called write ahead to log. So log is always the end of your operation. So using such a log, we can restore the data. Also, file system use the transaction. So what is a transaction? You probably use a lot of time, especially in the computer science or the computer engineering major. So I have a number of transactions. My transaction is failed. Could you send the transaction and so on? What is a transaction? What is the difference between transaction and the operation? Transaction and operation. Operation, example of operation is read, write, read, write. So think about the banking transaction. I'd like to transfer the balance money to my friend. This is one transaction. It should be done together. So to implement that one transaction to transfer, read the balance, whether I have enough balance, and minus, take out 100. And send the data to the other bank, your friend, account. Check whether it exists. So read and write and return back. It's done. Then finalize. A lot of operation. Read, write, send. Then by combining all of these operation, we consider this number of operation as one transaction. So transaction is atomic. Atomic means all or nothing. If something happens in the middle, even though first two operations are successful, but in the middle, one is to take out 100, but it's a fail. So you lose the 100. Nobody received the money. So at that time, restore. So because transaction is atomic, number of group of operation. So this transaction is used a lot to address the problem of the inconsistency. So file system also use such a transaction concept to keep the consistency. For example, database use very seriously, strictly use the transaction, the concept to keep the consistency of the data, the file system data. So that is a transaction. Okay. So I'm going to skip the NFS network file system, which is based on the file system. So there are okay. So that's the end of the chapter 12. One more time for those who are late. So GA and me realized that many of students actually copy and paste for your project 1. So those who are identified as a pressurized, your score is marked as a 0. So I'd like to give the second chance for the project 1. So due date is the end of Thanksgiving, that is November 25th. So GA GitHub will create the new submission site. So if you want to recover such a failed project 1, please solve the problem by yourself, not copy it. So some of the students say that I recycle, I use the existing one, but it doesn't mean that it can be excused because we realize that it's exactly copied from the couple of or the several 3 or 4 submissions are exactly same, even including comment. It cannot be excused. It's not possible. At least you need to put your effort. So that cannot be excused. So please try to solve the problem by yourself. So that even though it's incomplete, you will get the partial credit. But if you copy it, and also the friend copied mine. So I do not identify which one is source, which one is copied. As long as there exists the same thing, both of them will be considered as the plagiarized. Okay? So you don't have to say that I did it, but my friend is the copied, it will not be excused. So those who already did the project 1, so I'd like to give the 70% of the credit of the project 1, those who complete in the second chance. That doesn't mean you will get the 70%. So if you successfully finish all the requirements, you may get the 70%. But if one more time identified as the plagiarized, any plagiarism issues, so it will automatically fail of the entire class. So this course. So during the next week, you need to do the project 2 and the project 1 to those who fail in the first the project. Okay. We have talked about a lot the operating system and the system, the computer architecture and computer component. So I probably mentioned that we can regard any device connected to the computer system as the I/O device. This one is the CPU is also I/O device. Input and there's also input and output. Memory is definitely the primary source of the data from the CPU. So it's a lot of input and output. Because of that, the move instruction is the mostly used instruction in the assembly language. Then also other I/O devices, I/O peripheral like the mouse, keyboard, and touch screen, the display and network interface, or the other, all of them are connected and in the motherboard. So, which means one of the main job of the operating system is how to manage such a I/O. So, in this chapter, we talk about the CPU. We are not discussing the memory, but we would the memory and also the primary storage and the secondary storage as the file system, so on. So we mostly talk about such a the I/O device, but from the operating system point of view, so we will see how to manage such I/O operation in chapter 13. Then we will go back to the memory management in the next class and after the Thanksgiving. Okay. Then any I/O device has the very basic component, which is a port and bus and the controller. What's the meaning of a port? Bridge port. What is?
Like an access point.
Yes, it's access point. So think about the network. So the TCP/IP, you need the IP address as well as port. So each connection should have their own. It's a kind of a door to access. There's a door to the advisor. There is a door, another door for the classroom. So you need to use that specific door. So you need to connect any I/O device to the specific port. And this port is connected to the other devices. So connected means you can send and receive the data. So that is called the bus. Bus is kind of a daisy chain. So I'm really sick and tired to remove the weed and such a thing. It's keep connected, like the daisy chain sometimes it's called. So you have this one connected. Okay, so this is called the daisy chain side connection. Then the most popular one is a PCI and nowadays PCIe and there's the expansion bus. So like this one. If you open your personal computer, or if you have a chance to open your laptop, you may see such the adapter. So this the PCI It's used a lot before. Nowadays it's PCI Express. Also we have the AGP and the smaller one, so we can connect such a like I have graphic card.
Yeah,
so graphic card, so you can connect the bus. Okay. So that is the bus. Then finally it has a small computer, which is called the controller. It's an embedded computer, embedded the system, so that know how to manage the input and output for the specific device. Like if you connect the disk drive, you should connect the disk drive to the disk controller. That disk controller know how to access how to read and write, send the data. Okay, it's an embedded program. That is the device program. So because of that, long time ago, if you purchase a new hard disk drive, you need to get the new program and install the program, device program. Otherwise, you cannot use the new device. But nowadays, nobody did it because it's mostly either standardized, like the USB. Still, some of the students in computer science believe USB is for storage only. USB is what? It's a bus. So this layer, so universal serial bus. Okay, it's a kind of standardized nowadays. So we can use such a bus for storage. That's a USB, the disk. You can use this one for network. There's a network adapter for the USB. So you can connect the network adapter USB, then you can do the communication but through the USB. So you can use the USB mouse for the input and output, or using the USB for the mouse. So that is the USB, but the one way is standardized. Because of that, you don't have to install. Another one is your device program is already part of your operating system. So actually, the general purpose operating system, including Windows, the macOS, and such a company, they already released a roadmap of their development plan. They already have the 10-20 years of the future version. Then deploy to the company, like the hardware company or the storage company, like the Samsung or the Hitachi. They already knew the plan of the operating system, so they developed their device program that fit to the compatible with the new version of the operating system already verified. So it's a part of their operating system. So because of that, you don't have to worry about nowadays, but still we need such a device program for the control. Sometimes it's called the host adapter, so any of the device should connect to the controller. This controller is the kind of the small microcontroller. It has its own register for the input and output, and it has their own number of instructions. So you can read the data and keep the data and send back to the data through what? It's an inter. So it's an interface. One more time we will see the we have talked about the interface, the I/O. So this I/O device uses such an interrupt to send to receive the data. Okay, so this is I think we already saw this architecture before. We can see this is a PCI bus. Sometimes we have the expansion bus. The expansion bus usually is for low speed, not high speed. The device like the keyboard, the serial port, power port, and also disk controller is one of the most popular. The controller at the IDE disk controller, we have a number of the disks. And we have processor, monitor, and for the processor it has cache and the memory, and also caches and so on. So we will see such a I/O hardware based on the I/O. Okay. Only this one, memory map, the I/O. So when we read the data, for example here the processor, the interrupt. I need the data from the disk drive here, so send the request to here, and processor will move to the I/O way. Then the scheduler will select another process is running. Then the same time, this controller read the data and store the such a data in the here, the register. Then interrupt and send back to the processor. But cannot send the data to directly here. Instead, you need to store the data on the memory. Then the processor will read the data from the memory. Which means, if you do not have the location, specific location of the memory, each device to use it here and there, so memory, the CPU should check the always address of that location of the data. It will take a time. So instead to address that one, why don't we allocate the address of the specific location of the memory for each device, like this. So 000 is a 00F is for the DMA controller and interrupt controller timer and so on. It's called the memory mapped I/O. So memory mapped I/O is we can use the specific the location of the memory for each device. So CPU just always know where is the data received. If we interrupt from the disk controller, then using that designated the memory the address the read the data. So which is called the memory mapped I/O. Okay. So you can actually implement use the memory mapped I/O using the system library, system code. So if you want to use the memory mapped I/O, MMIO, MMP is like the system library. Okay, so we will continue the I/O management. I think we can finish earlier than move to the memory management in the next class. Then on Monday next week we will have the Thanksgiving holiday. Then we will meet again after Thanksgiving. We have the 2 weeks to finish. I think pretty much we can cover the most of topic, including if we have a time, we will talk about the blockchain, the lecture. That's a lecture one more time. Any questions? Okay, thank you, and see you next week.